Hello my dear students, once again welcome to your online class. Today we will be beginning the 5th chapter of your chemistry textbook, that is the mole concept and the stoichiometry. Okay, so this word stoichiometry, what does it mean? It means that the quantitative analysis of the gaseous reactant and the gaseous product is known as the stoichiometry. Okay, so we have already learned about the qualitative analysis or the analytical chemistry in the 4th chapter, and in this chapter we will be learning about the quantitative analysis of the gas. So to begin with this chapter, a short revision of what we had learned in class 9. So few of the laws that we learned in class 9 was Boyle's law. Okay, so Boyle's law. So what does the Boyle's law states? The Boyle's law states that the volume of the gas is inversely proportional to the pressure. So for the two stages of the gaseous, that is P1 V1 and P2 V2. So the mathematical expression of the Boyle's law was P1 into V1 is equals to P2 into V2, where the P1 and V1 is the pressure and the volume at the stage 1, and P2 and V2 are the stages of the gas at P2. The pressure and the volume of the gas at stage 2. Then we had also learned about the Charles law. Okay, so the Charles law stated that the volume of the gas is directly proportional to the temperature. Okay, so for the two stage, here it one was V1 divided by T1 is equals to V2 divided by T2. Okay, so this was the Charles law, which we have already learned in class 9. And then finally we had also learned about the gas law. Okay, so combination of both of these Boyle's law and Charles law to give us the equation of the form P1 into V1 divided by T1 is equals to P2 into V2 divided by T2. Okay, so this was the mathematical expression of the gas law. Okay, so this is just the revision of what we had learned in class 9, and this chapter completely deals with the numerical problem. Okay, and it also contains a greater marks in your ICSE board examination. So a new thing that we learn in this chapter is Gallucci's law. Okay, so Gallucci's law. So what does the Gallucci's law say is, the Gallucci's law states that whenever the gases react, okay, they do so in volume that they always bear a simple ratio to one another and also to the gaseous product. So what does this mean? So let us understand with the help of the simple example. Like a hydrogen, it combines to form a water. Hydrogen combines with the oxygen to form water. Okay, so we know that. Now you need to balance this equation. Okay, so on balancing, I have two hydrogen, oxygen atom 1, here 2. So I'll write here 2, and then I'll write 2. So now it is completely balanced. Hydrogen 4, oxygen 2, and oxygen 2. So now, so let us take the first number of each of the quantities. So this is the reactant, and the other side is the product. Okay, so the Gallucci's law says that whenever the gases react, they always react in the simple ratio to one another. Here the ratio of hydrogen to oxygen is 2:1, and also the water produced is 2 volumes. Okay, so this is what the Gallucci's law says. Like you cannot combine a 3 ratios of water with a 1 ratio of water to produce a 3 ratios of water. Okay, so they always combine in a simplest ratio. Like suppose if I want to create like if I have 4 volume of hydrogen, so according to this, whatever is the volume of hydrogen required, the half of it, the oxygen is required. So 4 means I need here 2. Now whatever, if here I have 2, there also I have 2, so here I have 4. So the 4 volumes of water combines with the 2 volume of 4 volume of hydrogen combines with the 2 volume of oxygen to produce a 4 volume of water. So this is what is the Gallucci's law. So you also must remember the statement of a Gallucci's law, which tells us that whenever the gases react, they do so in volume that they always bear a simple ratio to one another and also to the gaseous product. So we'll be drawing few of the numerical based on the Gallucci's law, and which will come in your examination as well. Okay, so now considering the same equation, suppose if I have 5 liters of hydrogen, I have a 5 liters of oxygen, and I have how many? I have 2 liters of oxygen. Okay, so now what happens? So according to the Gallucci's law, the 5 cannot react with 2. Okay, so if I have the 2 volume reacts exactly with the half. So if I have 5 volume of oxygen, hydrogen here. So 5 would have required 2.5, but I do not have 2.5. So instead what will happen? The 2 volume of oxygen will exactly react with the double of it, like the double of hydrogen will be required. That means the 4 volume of hydrogen will be used by the 2 volume of oxygen. So what happens? 1 volume of hydrogen it is remaining. Okay, so we see in this equation that in this case what happens? The oxygen is completely used up, but whereas the hydrogen is remaining. So whenever the gases react, whichever gases is completely used up is known as the limiting reagent. So here the oxygen is the limiting reagent. Okay, so it's important to know what is the limiting reagent. So the limiting reagent is the reactant that is completely used up during the chemical reactions. So another important law in this chapter is the Avogadros Law, which is very easy to state. So the Avogadros Law states that at equal volume, at the same condition of temperature and pressure, the equal volume of all the gases contains the same number of molecules. Like if I have 3 containers, okay, of equal volume, suppose I assume this container to be 10 liters each, okay, and the temperature being constant throughout, that is 30 degrees centigrade, and the pressure also being the same, let it be 1 atmosphere. In one of the cylinder I have nitrogen, other I have hydrogen, and in another if I have chlorine gas. Okay, so here what happens, the volume is also same, the temperature is also same, and the atmosphere is also same. So the Avogadros law says that all of these will contain the same number of molecules. So that is what is the Avogadros law. Equal volume of all the gases under the similar condition of temperature and pressure contains the same number of molecules. Now we'll try to solve few of the numericals related to the Gallucci's law. So from your textbook exercise 5a, I have chosen question number 6. So the question tells us what volume of oxygen would be required. So what volume of oxygen will be required to burn completely the 400 ml of acetylene, that is C2H2, and also you have to calculate the volume of carbon dioxide produced. Okay, so you need to measure the 2 of the quantities. So before starting, so let us see what are the simplest ratio. Okay, so here I have 2. Okay, 2 means I'll take the number which is in front of the given compound. So here I have 5, there I have 4, and here I have 2. So clearly I see that the 2 volume of oxygen combines with 5 volume of oxygen. Okay, so this is the simplest ratio. Now what is given in the question? In the question it's given that now the volume of acetylene is 400 ml. Okay, so asked how much oxygen is required. So you may simply use the unitary method to find the volume of oxygen there. So to begin, so 2 volume of C2H2 requires how much? It takes the 5 volume of oxygen. Okay, so therefore the 1 volume of ethylene, sorry, not ethylene, this is acetylene, it needs 5 divided by 2 volume of oxygen. So in the question it is asked how much the 400 ml requires. So therefore the 400 ml of acetylene will require 5 divided by 2 into 400 ml of oxygen. So simply 2, how much? 200. So this will be equals to 0, 0, 5 to is 10 ml. So it's clear that for 400 ml of acetylene, the 1000 ml of oxygen will be required. Now the second part is, so this is the part 1. Now coming to the second part of the equation. Okay, so it's also asking what volume of carbon dioxide will be produced. So simply we see that the 2 volume, it produces 4 volume, that is exactly double. Since 2 volume of C2H2, it gives how much? It gives 4 volume of CO2, that is exactly the double. So therefore in the question, the 400 ml of acetylene will require how much? Now the double of 400 is 800 ml of CO2. So it's so simple. Okay, so this is how we solve the numerical based on the Gallucci's law. So here I have taken again question number 11 that came in the year 2017 in the ICC board examination. So the question says what volume of propane, okay, so this is propane. So what volume of propane is burned for every 500 centimeter cube of air used in the reaction under the same condition. So 500 centimeter cube of air is used, but here I do not have air, I have oxygen. So assuming that the air, it contains only 1/5 of the air. So first let us see the simplest ratio. So 1, here I have 5, I have 3 and I have 4. So according to the question, 500 centimeter cube of air is contained and only the air contains only the 1/5 and the air contains only 1/5 of the oxygen in it. So first let us, so amount of air. So how much air is used? The air used is 500 centimeter cube. Okay, so according to the question, okay, only 1/5 is oxygen. So therefore, what in 500 centimeter cube of air, let's say how much oxygen is there. So therefore, amount of oxygen will be equals to 1 by 5 into 500 centimeter cube. So 5 ones are 100, so equals to 100 centimeter cube of oxygen is present. So now it's just like saying the 500 centimeter cube of air is used and the 100 centimeter cube of oxygen is used is the same sentence. It means the same thing. So now I'll write here 100 and question mark. Okay. So now according to this, 5 uses 1 volume. So the 100 will use how many? So let us try to find. So now, so I'll do in this way. So oxygen here and then I'll write the propane C3H8. So when the oxygen used was 5 volume, so the propane used was 1 volume. So now therefore when the oxygen used will be 1 volume, so what will be the propane used? It will be 1 divided by 5. Now according to question, what is the amount of oxygen is 100. So the 100 centimeter cube will be using how much? It will be 1 divided by 5 into 100 centimeter cube. So 5 ones are 5, 2 and 0. So therefore, how much propane will be used? So the propane used will be simply, it will be 20 centimeter cube. Okay. So you may also write that for every 20 centimeter cube of propane, the 500 centimeter cube of air is used, or for every 20 centimeter cube of propane, how much? 100 centimeter cube of oxygen is used. Okay. So there are many numericals which are very simple. Okay, you may try to solve each of them so that in the next class we may proceed into the next part of this chapter. Thank you.